For your name, we're going to be calling names every now and again and giving away some free stuff. Free stuff, yes, all right? So I know some of you guys are still waiting for beer, hang tight. That'll hopefully happen soon. But right now, we are going to start with a good friend of mine, Sarah. She's going to talk to you a little bit about looking at dementia in our furry relatives. So please give a nice round of applause for Sarah Fontaine.
All right, definitely not as tall as Krishna. Hi, everybody. So I'm actually going to start my talk by not talking for a certain period of time. I'm going to start right now. Okay, I lied. I have a timer going, just so you know. That was 67 seconds, so 1 minute, 7 seconds. Every 67 seconds, somebody is diagnosed with Alzheimer's disease or another type of dementia. So I know that seemed like a really long time, sitting here staring at me, looking at the timer on my phone, but it's really a minute. So every minute, somebody in the US is diagnosed with dementia. So let's just start with a little bit of background on dementia. I'm going to pop my phone down. So dementia is really a broad way to categorize memory or thinking disorders or symptoms that interfere with how you live your daily life. So these are memory loss, an inability to cognitively make decisions, a lack of judgment, a lack of reasoning, problems with your visual perception. All of these blanket under the symptom of dementia. So I would like anybody who has a relative or knows somebody, a friend, a neighbor who has Alzheimer's disease or Parkinson's disease or anything, any other type of dementia. Could you raise your hand? Okay, can you look around at how many people have their hands raised? That's incredible. And the number of people who have Alzheimer's disease is going to triple by the year 2030. So I should probably get my skates on and figure out how this disease is working. So Alzheimer's disease is the 6th largest leading cause of death in the US. And it's the only one that we don't have a treatment for. No treatment, no cure. There is nothing we can do about it right now. There's a lot of stuff that we're doing in clinical trials. But the question is, how do we test memory in such a way that we can actually determine if we're making a difference or not? And so this kind of leads me to what I'm trying to talk about today. And that's looking at dementia in other organisms and why looking at dementia in other organisms may not actually be a very good exact replica for humans. So let's talk about diseases and aging and how us noble scientists or, overworked postdocs in the lab, how do we actually look at aging? What do we do to look at aging? So we like to use model organisms. And the simplest of these are bacteria and yeast, so unicellular organisms. Hooray. But the problem is, how do you ask a bacteria to think? You can't ask it to do a memory task. It just multiplies itself, but it's very useful for growing up the proteins that we need to look at in the brain. So we'll replicate tau, or A beta, and I'll talk to you a little bit more about those in a second, in the unicellular organism. And we can manipulate their genetics, and we can mutate the proteins. And so we can kind of look at it at a very simplistic molecular level. But it's not really replicating what's happening in a human. So you think, okay, well, there are other model organisms we can use, for sure. Flies, Drosophila, everybody has fruit flies flying around. Some labs more than others, if they have escapees. And also, we can also use C. elegans, which is a worm model. Again, problem, how do you judge memory in one of these organisms? So what is memory? So when you think about memory, what do you think? What do you think memory is?
The duration of time that something is retained.
That's good. That's one way of looking at it. Anybody else have, how do you perceive memory?
Compartmenting your brain that holds information.
Anybody else have any, yeah?
The ability to recall something.
That's true. So, the ability to recall something when you need it. And so the ability for us to recall something when we need it relies on a concert of neurons in our head firing at the same time every single time we need to recall a memory. So every time that you want to go home, you need to remember how to get home. And it's those same set of neurons in your brain that are firing, oh, this is how I want to get home. But how do we test this in an invertebrate animal? So with flies, we can kind of look at their locomotor ability. Can they crawl up the side of the glass? Or do they have problems crawling up the side of the glass? We can look at if their actual neurons are degenerating, if they're getting sick, if they can't fire. We can tease out all of those little molecular things, but we still can't ask a fly to remember how to get home and expect an answer. And we can't ask a worm, do you remember where you were a year ago? No, they weren't even alive a year ago. Their lifespan is so short. So using those models is actually pretty difficult to try and judge memory. We can look at genetic components of memory. We can look at the proteins and the genes that are involved in actually coordinating the neural networks. But we can't actually see if we're making any of the memory recall in terms of your grandparents, or your great-grandparents, or your mother. We can't actually ask if that's an improvement. So I think, okay, fine, Sarah. Those are invertebrates, come on. What about a mammal? What about a vertebrate? Okay, well, how about fish? So fish are a popular model organism. Do they get dementia? Not really, no. No, they really don't. But they are fast, and in the lab we like things that mature quickly and can stay alive long enough that we can see if the neurons are degenerating. But they don't actually get dementia unless we manipulate them to get dementia. Same with mice. So a lot of people here use mice. I use mice. We can test memory in mice, where we can't really test memory in fish. We can just test how fast they swim and if they swim in circles or around the perimeter or if they float. That's all we can do with fish. But for mice, we can actually do the same thing. So we test if they float. We test if they remember where things are. If they put them in a pool and they swim to a platform and like, yes, I found the platform. Some of them don't. We can test if they remember a stimulus. But we still can't ask them, you know, what did you have for dinner? They would just be like, mouse chow. That's all I eat. It's great. So the question is, how do we do our science then? How do we use these models? There are other models too. There are rats. Somebody was trying to make a transgenic model of pigs. Somebody erroneously tried to make a transgenic model of sheep. Anybody who has ever been around a sheep knows that there's no way you can test cognition of that animal. Take it from me, I grew up on a farm. Not the sharpest animals in the shed, to be putting it mildly. So then, you kind of think about higher order vertebrates besides the mouse models, the rat models. And so we come to cats and dogs. And here's the interesting thing about cats and dogs, is that, I don't know if any of you have any elderly animals, but cats and dogs can get a form of dementia. And the really, really interesting thing about this form of dementia is that the pathology, so the problems that we see in the brain tissue of these affected animals, is really, really similar to what we see in humans. So dogs get something called canine cognitive dysfunction syndrome, or dogzizers, apparently, is the internet term for this. And what it is basically is really, really old dogs start to have behavioral problems that they didn't have before. They and actually that's how it mainly manifests, is you see weird behaviors that, Fido wasn't doing before. What happens is when you look at a brain of a dog who's had this disorder, is you see all these little clumps of protein in the brain. And so these clumps of protein are clumps of A beta, and so we call these plaques. And so what this is a protein which is normally produced in, varying amounts as needed in a healthy brain. But when you age, you start to lose the ability to clean up any messes in your cell and get rid of proteins who are there, who are not supposed to be there. Your mitochondria, which are the powerhouses and provide energy for all the reactions in your cell, that starts to dysfunction, not work as well, build up toxic species. And there's a whole host of other causes that instead of this A beta getting cleared away nicely, it actually gets secreted and starts to clump together. So we see these clumps of plaques of A beta in canine brains. And we actually also see the same thing in cat brains. So I know behavior in a cat is kind of hard. I have 2 cats, so their behavior consists of sleeping all day, interspersed with very, very brief periods of fighting, which pretty much looks like them patting each other on the head and then jumping on each other. And then they run around like crackheads, and then they sleep for another 20 hours, right? So you're thinking, okay, well, how do you determine abnormal behavior in a cat? Good question. But it is actually, you do find that some of the elderly felines do get a form of dementia. So they have some behavioral problems, which their owners probably noticed. Maybe they stopped fighting with each other and just stared at each other for a while and then went back to sleep. I don't know. But again, you look in the brains of these animals and you see A beta plaques. And in very, very, very elderly animals, so, if you've had a dog who is, 15 over, if you have a cat who's 20 plus, you also start to see clumps of another protein, which is the protein that I work on, which is called tau. And so tau is actually a really interesting protein because it stabilizes your microtubules and your axons. So what that means is that it gives structure to your brain cells. So it's really, really important, and it's really important for signal transduction. But only in the really old animals do you see the tau accumulations as well. So you think, okay, great, well then let's just use old dogs and cats to model human behavior. Have you ever tried to get a cat to do anything that it didn't want to do? Just asking. No? Yeah, try giving a cat a bath. It doesn't want to have a bath, and it looks like, a horror movie. So perhaps you can't train a cat to do a task either. Like sometimes you can train a cat to, say, use a toilet instead of using a litter box, but let's be honest, that amount of training is not conducive to scientific research. I don't care how many grad students I have, I don't think I could convince any of them to try and train a cat in a behavioral task. So I guess if you're thinking to yourself, okay, we've gone through bugs and yeast and bacteria and mice and cats and dogs, so where does that leave us? So a lot of people think, okay, well let's use non-human primates. And let's see, they might get dementia too. So if we look at non-human primates, we actually do see A beta plaques, and we do see tangles, and the primate brain more closely matches our brain metabolism. But they still don't really get Alzheimer's disease. So, for a whole host of complex genetic reasons that we don't even know about yet, and for a host of really, really complex cellular dysfunction, lifestyle, diet, all of these factors combine to cause a really uniquely human disease of Alzheimer's. So the speech part was a little bit short because I know so many people are affected by Alzheimer's disease, and I just really wanted to open this up to a discussion about why do you think Alzheimer's disease is such a human disease, even though we see pathology in other animals. And what kind of thoughts do you have about how memory might make us uniquely human, or maybe that doesn't happen with our furry friends?
Yeah. I just have a thought or a question. Is this studied worldwide, or is this do we have the knowledge worldwide, or is it diagnosed worldwide?
Yeah, so Alzheimer's disease is actually the most prevalent dementia worldwide. So there are labs all over the world who work on this. There are
When did we start
populations-
calling it Alzheimer's versus just dementia? When did that become?
So Alzheimer's, the classical Alzheimer's was described by Aloysius Alzheimer, which is awesome. I wish I could describe a disease and then it could be Fontaine's disease, but I think I'm a little late to the party. So in 1906, he was actually describing a patient who had severe memory problems, didn't seem to know where she was, got worse at night, liked to go wandering, which is another classic symptom, couldn't reason, and he described her symptoms, and that's where we kind of got with the